Respected judges, today we address a crucial yet often ignored problem in Indian sports, the lack of timely talent assessment. Think of the great cricketer Mahendra Singh Dhoni, who actually started out in football. His story is inspiring but also reveals a bigger issue. Countless young athletes remain unnoticed not for lack of skill or dedication, but because there is no proper early stage system to identify and guide them, especially in rural areas where financial support is limited. India has over 750 million smartphone users, yet less than 0.1% have access to structured sports talent assessment. If we act now, rural sports can rise from 22% to nearly 88% by 2030. Our solution, KHELO Sathi, makes professional level assessment possible through just a phone. The app measures an athlete's height via mobile camera, captures a short video, and runs AI analysis directly on the device, even offline, before submitting results to the server. Unique advantages of our app includes offline AI video analysis ideal for low connectivity areas, height calculation and detection from video using advanced trigonometry, something no other app offers. Benchmarking with elite athletes plus a personalized diet and exercise plan with actionable tips are some additional features. With Khelo Sathi, the hidden talent, whether they are from a remote village or a big city, they finally get the platform and recognition they deserve.
Now it's time for enlightening the technical approach and the system architecture of our project. We have divided it into 5 major parts. The first one is training and development phase, where we collect the data and pre-process it using pandas, in which we use the classification algorithm to train the model in TensorFlow. So from that, we are getting the event detection model. In parallel, from the video input, the video pre-processing will be done by OpenCV, and we extract the body landmarks of the athlete using MediaPipe to get the fine-tune of pose estimation model. From the video pre-processing, we are calculate the distance between camera to object. Now coming to the deployment of ML models, we are getting two ML models and we have converted into .pf lite format, which is nothing but the TensorFlow Lite format, which is used for deployment of machine learning models. From the event detection model, we detect the event and we apply the pose estimation model in that event to get the landmark and pose skeleton of the athlete, by which we detect the posture. In parallel, distance between camera to object will be calculated by RoboFlow. Then we are applying trigonometry and Pythagoras theorem to calculate the exact height of the athlete. Now, as we are using TensorFlow Lite, when the user will download our app, the two ML models will be automatically downloaded in the mobile of the user. That's why our estimated app size will be 30 to 40 MB. Now coming to the on-device calculation part, as we get the posture, we partitioned it into angle between joints, run and jump. From the angle between joints, we are counting the repetitions like push-ups, sit-ups, etc. From the jump, we are calculating the vertical jump height, and from the run, we are getting the top speed, average speed, and the acceleration. All of these calculations will be done by vanilla JavaScript. That's why our system will be very much faster. Now the next part will be explained by my fellow friend.
Now let me walk you through what the user really experiences in our app. First, we have built the app using React Native so that it can work on both Android and iOS. The journey starts with authentication, for which we have used Firebase. After authentication, the user can navigate through our app, but before pre-assessment, the user have to detect his or her height from our app. For pre-assessment, the user have to capture a live video or upload a recorded video, from which we are going to check if the video is corrupted and if the video duration is under 1 minute. Here 1 minute because we want the same standard for every athlete, and if both the condition satisfies, we got the pre-assessment result, and the result will be stored locally using SQLite so that the result can be accessible even offline. And if the result is under threshold, we will suggest him improvement suggestions. Here the threshold will be defined by SAI itself, and if the results are above threshold, the video will be stored in Amazon S3, but we won't be storing the video directly as we want to remove any type of biasness. So we are going to store the post skeleton video of that athlete in the Amazon S3 and get back the video link. Now the pre-assessment data and the video link will be stored in Amazon DynamoDB, which will be encrypted using a secret key. Now from there, a report will be generated and will be sent directly to SAI. Now I will show you the prototype of our mobile app. This is the registration page. From here, the athlete can register. So this is the profile page. The user can put his or her details here, and this is the assessment page. In this assessment page, we have divided the assessment into two segments: indoor assessment and outdoor assessment. So here are the available tests for indoor assessment, and here is the available test for outdoor assessment. This is the leaderboard page. The user can see the leaderboard here and where he or she stand among other athletes. And this is the result page. The user can see their performance result, the pre-assessment results here, and their progress, their performance trend, their score breakdown. This is the tips section. The user can see personalized tips for themselves. And here is the achievements. And this is the settings page of our app.
Now we will show you that how the counting repetition will be done in our project. So now I am going to show that the bicep counting for the barbells. So let's see the result. So here you can see that we are calculating the angle between shoulder, elbow and wrist. Then we are calculating the repetitions. Similarly, we have built it for the push-ups. So now let's see the push-up counting. So similarly, a threshold value will be generated, and then we are calculating the angle. If the angle above the threshold, then count will be increases. Let's see this prototype. So first of all, let's see the original input video of this prototype. So here is the original video. A person sit in the chair and then sit up from the chair and walk through the dais. So this is the original video, and as the security concern, and we have already mentioned that we will not disclose any personal information or even the face of the user or the athlete to anybody, not even to the site. So how we can achieve that? This is the prototype of that system. So we will not store the original video of the athlete with their face. We will store only the post skeleton video of that athlete, so that we will remove the bias from the total sports assessment system. So this is our aim. So here you can see that the person with the only the post skeleton video with the same background. So this is our prototype. So that's all. Thank you all.